Swayam Prabha. Digital India. Educated India.
So, last class I have discussed that how we can determine the moment due to the friction force that is acting along the side of the well, and then I discussed about the rectangular well. Now, today I will discuss for the circular well first. So, that means here the equation of the MF. So, that is 0.183 gamma dash, because if this is 1.1 divided by 3, then also divided by 2. So, finally, it will be 0.183 gamma dash Kp minus Ka, then L B d square sin delta. So, finally, I can write that MF is roughly 0.183 it was. So, I can write 0.180 gamma dash Kp minus Ka into L B d square sin delta. So, this is one equation of MF. So, this is for square or rectangular well. Okay. Now, for circular well, the MF is equal to 1.13, this is gamma dash d square Kp minus Ka. So, sin delta, so into L. Now, here B by 2, you have to B by pi. So, that is the only difference. So, this is B by pi. Okay. Now, it is recommended that for circular well, L is equal to 0.9 0.9 d. D is the diameter of the, or d 0. Okay, so, this is d 0, where d 0 is the, or here also I can write this is also d 0. So, d 0 is the outside diameter Okay, so this is the outside diameter of the well. So, in the previous cases we have considered, in case of Tazaki's analysis also, the L is equal to the diameter of the well if it is circular well, but this time it is recommended that L should be the effective length or side length should be slightly less, so compared to the diameter. So, that is 0.9 of the d. Now, finally, if I put these values, so you will get that MF is equal to 1.13 pi gamma dash d square Kp minus Ka, then sin delta into 0.9 d 0 into d 0. Okay. And and this will be MF will be roughly 0.11 gamma dash d square, or I can write this one first. Okay, gamma dash d square Kp minus Ka. So, this is T 0 square into sin delta. So, 0.11 gamma dash d square Kp minus Ka d 0 square sin delta. Okay. So, this is for circular well. So, now these MF, then MS and then MB, this MB, these are the resisting moment. Okay. MB is because of this the friction force which is acting along the slip surface. Then MS is because of the soil resistance, that moment, and then MF is due to the friction between the soil and the side wall. So, these are the resisting moment. So, the condition should be that if M is the applied moment, then this M should not be greater than 0.7 times of MB plus MS plus MF. So, this MB plus MS plus MS, so these are the resisting moment. Okay. So, and 0.7 times 7 is the reduction factor in the strength. So, this is you should say some factor of safety is applied. So, we have reduced the resisting moment. So, give some factor of safety. So, that is the reduction of the strength due to the reduction of the strength, or we have applied some factor of safety. So, that means that we have taken not the full resisting moment, we have taken 70% of that. So, that in the applied moment should not be greater than the 0.7 times of the resisting moment, or I should say the 0.7 times of the resisting moment should not be less than M. So, this or other ways. So, and another condition. So, this is the one condition. Okay. This is the condition 1, and another condition that W by A, the vertical force divided by total area of the well, should not be greater than Q U by 2. Okay. So, this is the condition 2. Now, what is W? Is the total vertical weight, A is the area of well, and definitely the outside area. Then Q U is the ultimate bearing capacity of the soil below the well base, and this 2 is the factor of safety. Okay. So, that means A is the area of well, QU is the ultimate bearing capacity of the soil below the well base, and 2 is the factor of safety. Okay. So, this is condition 2, and here you can say this 2 is the factor of safety. So, these two conditions you have to check for the ultimate soil resistance method, and then we have to check the 3 conditions that I have discussed, that is for your elastic theory method. Okay. So, now I will solve one particular example problem, and then I will show you how we can use these conditions. So, example problem, that the W, the total vertical weight including the self weight, that is equal to 5000 kilonewton. Okay. The horizontal force H is equal to 1000 kilonewton, and the moment at scour level, that is equal to 3500 kilonewton. So, both are acting at scour level. Then the depth of well below scour level, that means D is equal to 14 meter. Then gamma dash, submerged unit weight of the soil, is 10 kilonewton per meter cube. Phi is given 35 degree. Delta is 2/3 of phi, but it should be restricted up to 22.5 degree. So, it is taken 22 degree. Now, outside diameter of the well is 5 meter. Inside diameter of the well is 3.5 meter. Now, allowable bearing pressure of the soil of the soil is equal to 300 kilonewton per meter square, and Q ultimate is equal to, say, if I apply a 2.5 factor of safety, say it is 750 kilonewton per meter square. So, this is for the soil. Okay. Now, we have to first do it by elastic method. And we have to check whether these conditions are or these values are sufficient to make the well stable. So, here it is given the L is equal to 0.9 d0. So, this is for the circular well. Okay. So, it is a circular well, 0.9 d0. So, 0.9 d0 is equal to 5. So, this is 4.5 meter. Similarly, the IB is equal to pi d0 to the power 4 by 64, that is for circular footing or circular well. Now, for the rectangular well, suppose this is B, this is L. So, your IB will be L B cube divided by 12. This is for rectangular well. Okay. Now, our case it is circular well. So, we will write pi 5 to the power 4 divided by 64. So, this is 30.7 meter to the power 4. Then IV is L d cube by 12. Okay. Now, L is here 4.5, d cube is 14. Okay. So, d cube is 14 or to the power cube, d is 14, this is 12. So, 4.5 14 to the power 12 divided by 12, 14 to the power cube divided by 12, this is 1029 meter to the power 4. Okay. So, now I is equal to I b plus m I v 1 plus 2 mu dash. Okay. So, this is the equation, these equation I have already derived. So, now take m is equal to 1, that is k v is equal to k h. So, that is that we have assumed, and mu dash is equal to tan delta, and delta is 22 degree. So, tan 22 degree. So, this is equal to 0.4 and mu is tan phi. Okay. So, now alpha, because there is a term alpha, alpha is given how much? Because alpha is given d 0 divided by pi d, that is for circular well, and alpha is equal to b by pi d, that is for rectangular well. Now, our case it is circular well. So, this is d 0 is 5, pi, d is 14. So, this is 0.114. Okay. So, now I can write that I is equal to, or I can write I is equal to I b plus m I v 1 plus mu dash alpha. Okay. So, this is the correction, this is mu dash alpha. So, this will be the 2 mu dash alpha. Okay. I b plus m I v 1 plus mu dash alpha. So, I will put this value. So, I b is 30.7 plus m is 1, I v is 1029, this is 1 plus there is a 2, yeah. So, that I have not written here. So, this is 2, mu dash is 0.4, alpha is 0.114. Okay. 1029, 1 plus 2 mu dash and alpha is 0.114. So, this is 1153.5 meter to the power 4. Now, R is given d divided by 2 I by m I v, that is equal to R. So, I can write d is 14 divided by 2, then I is 1153.5, m is 1, I v is equal to 1029. So, this is 7.85 meter. Now, for the first check, to check okay, so first check that h should be greater than m by r 1 plus mu dash minus mu w. So, now m by r 1 plus mu dash minus mu w, that is equal to m is 3500, the moment applied moment, and the r is 7.85, 1 plus the mu is tan phi, that means tan 35 degree, and that is tan 20 degree, or directly you can write 0.4 also. So, minus again mu is tan phi, tan 35 degree, and w is 5000. So, that value is minus 2929 kilonewton. Okay. So, H is greater than minus 2929 kilonewton. So, which is safe, because H is 1000 kilonewton. So, now I will do the second check. So, that check is 8, H should be less than m by r 1 minus mu dash plus mu w. So, if I take m by r 1 minus mu dash plus mu w, that is equal to 3500, r is 7.85, then 1 minus tan 35 degree, tan 22 degree plus tan 35 degree, then into 500. So, that is 3821 kilonewton. So, H is less than 3821 kilonewton. So, that means it is safe, because H is 1000 kilonewton. So, it is safe. Okay, so, now I will do the next checking. So, next one is that m small m into capital M by I should not be greater than Kp minus Ka gamma dash cos delta. So, that is the equation. Now, according to Coulomb's theory, that for phi equal to 35 degree, delta is equal to 22 degree, that Ka is equal to 0.245. So, you can calculate this, because we know the equation of Coulomb's active earth pressure and passive earth pressure coefficient. You put these values, I is also 0, because it is not an incline. So, I is also 0, then beta, this is the vertical phase. So, beta will also be, that beta is also be 0. So, that means here it is not inclined. So, this is vertical phase. I am talking about, this is beta. Okay, for a wall, this is beta. Okay, so, this beta is now 0, because the wall is perfectly, your wall is, the side wall is perfectly vertical. So, that means here this beta is will be 0. So, beta is 0, I is 0, I is means that this inclination of the black field. So, here back field also flat. So, I is 0, beta is 0, delta is 22 degree, phi is 35 degree. If you put these values in the Coulomb's equation, you will get K is equal to 0.254 and Kp is equal to 9.2. So, now if I put that small m is equal to 1, capital M is 3500 applied load, applied moment, and I is how much? 1153.5. So, I is 1153.5. So, that should not be greater than gamma dash is 10, Kp is 9.2, Kp is 9.2 minus 0.245 into cos delta. So, cos 22 degree. So, this is equal to 3 and that is not greater than 83. So, this side is 83. So, it is safe. Now, I will calculate, I will check the next one, that is m max, sigma max, sigma mean. So, that is W minus mu dash p divided by A plus minus m by I into b by 2, or here b by 2 will be d 0 by 2, because here it is circular well. Now we know that P is equal to m by r. Okay. So, now if I replace P is equal to m by r and A is equal to pi d 0 by 4 divided pi d 0 square divided by 4. So, I can write, so this is equal to W is 5000, okay, minus mu dash is tan 22 degree and P 0 is m by r, m is 3500 minus r is 7.85, r is 7.85. So, this is 7.85, then divided by pi 5 square divided by 4, then plus minus m b is 3500 and I is 1153.3, I is 1153.5. Then d 0 is 5 divided by 2. So, 5000 minus tan 22 degree into 3500 divided by 7.85, because we have replaced P by m, P is equal to m by r, because I have derived that P is equal to m by r in my previous lectures. Then pi 5 square divided by 4 plus minus 3500 by 1153.5 to 5 by 2. So, that is equal to 246 plus minus 7.6. So, sigma max is 253.6 kilonewton per meter square, and so which is less than 300 kilonewton per meter square. So, that is the allowable bearing pressure of the soil. So, it is safe. Okay, and sigma mean is also 238.4 kilonewton per meter square. So, negative pressure is also not developed. Okay. So, that means we have done all the checks, and under these conditions or these values or these configurations, the well is stable. Now, we will do the same problem by the ultimate resistance method. Okay. So, ultimate shear resistance method, the condition is given, two conditions we have to satisfy, that W by A should not be greater than Q U by 2, okay, where 2 is the factor of safety. So, W is here 5000 pi by 4 5 square, that should be greater than, should not be greater than 750 divided by 2. Okay, because I have given Q ultimate is 750 kilonewton per meter square to 254. Okay, 254. This is not greater than 375 kilonewton per meter square. So, it is safe. Okay, now I will do the moment checking one. So, MB, I have to calculate the resisting moment. So, MB is given Q, WB and tan phi. Okay. Now, D by B or D by D0, I should say first, because it is we have to use that table itself, then we will convert it. So, D by B. So, this is equal to, you consider the 14 by 5, take B is equal to D 0. So, this is equal to 2.8. So, 2.8 yeah, this is 2.8 and this is beyond this 2.5. So, we have taken, it is close to 2.5. So, we have taken 0.64. Okay. So, we have taken 0.64. So, Q is equal to 0.64, but this is for rectangular or square footing. So, for the circular rectangular square well. So, for the circular well you have to multiply with a shape factor of 0.6. So, that for circular well Q is equal to 0.64 into 0.6, that is equal to 0.4. So, this is a shape factor. So, now if I put these values, so this is 0.4, W is 5000, now B is equal to D0, so that is 5 into tan 35 degree. Okay. So, that is equal to 7002.1 kilonewton per meter or 0.7 into 10 to the power minus 10 to the power 4 10 to the power 4 kilonewton meter. Now, ms for the circular well. So, ms is 0.1 gamma dash d cube kp minus ka into L. Okay. So, this is equal to 0.1, gamma dash is 10, then this is 14 cube, then kp is 9.2 minus k is 0.245. Now, L is 4.5 because we have already multiplied that and we will get 4.5. So, this is equal to 110,576 kilonewton per meter or 11.06 into 10 to the power 4 kilonewton meter. Now, we will calculate the MF, moment due to the friction, and for the circular well this is 0.11 gamma dash Kp minus Ka, this is d square d0 square sin delta. Okay. So, this is 0.11 into 10 into 9.2 minus 0.245 into 5 square into d0 is 5 square, d is 14 square into sin 22 degree. So, this is equal to 18081 kilonewton meter or that is equal to 1.81 into 10 to the power 4 kilonewton meter. So, the resisting moment Mr, that is equal to 0.7 times of Mb plus Ms plus Mf. So, that is equal to 0.7 times of Mb is 0.7 plus 11.06 plus 1.81 into 10 to the power 4. So, that is 9.5 into 10 to the power 4 kilonewton meter. And the applied moment which is applied, so that is equal to 0.35 into 10 to the power 4 kilonewton meter. So, thus M is not greater than the 0.7 times of Mb plus Ms plus Mf. Okay, because M is 0.35 and we have a resisting moment of 9.5 into 10 to the power 4 kilonewton meter and applied moment is 0.35 into 10 to the power 4 kilonewton per meter. So, it is safe. So, we have checked this well stability using both the methods, elastic analysis as well as the ultimate resistance method, and both the methods are giving the safe design. Okay, so it is indicating that this well is stable. So this is the end of the well foundation. In the next class, I will start a new topic, which will be a very small module. So that is the foundation on difficult soil. Thank you.